are your coding bat problem sets, something called array list, which you'll be utilizing in Asteroids Part 1, or Asteroids Part 2, and Asteroids Part 2 is also due Friday. The following Friday, Part 3 will be due, where you complete the game. And I think Mr. Simon and I are talking about making Part 3 optional. We'll see. We're also going to finalize what we're going to do with the final in the coming days. So we're meeting today to discuss that. Let me clear my annotations and begin talking about what you need to know for Asteroids Part 2. If you have any questions or comments, do feel free to type into chat. Close this, close this, close this. Now we have to fall back into the routine of doing online school for another 2-3 weeks. Thanksgiving break was just long enough to mess up my sleeping patterns and all the good habits I developed. Right? Like, how many of you went to sleep at like 2-3 a.m. and then woke up all groggy and cold? I know I did. Okay, so the new part in Asteroids Part 2 are the asteroids. Notice that the asteroids, as they float around, they move very differently compared to the ship that you worked on in Part 1. So you're building off of your code in Part 1. You're resubmitting that link to Google Classroom. So asteroids are a little bit different. They rotate, or specifically they use the turn function inside the floater class while they move. Let's focus on like one asteroid in particular. Let's see this slower moving one. This one right here. It's turning clockwise, clockwise, keeps going, turning, and moves up. Yeah. So, as you can imagine, in Asteroids Part 2, you're going to make an asteroids class, and it's going to inherit a bunch of things from floater. You'll need to encapsulate things. I think that's the most important part, so don't forget to add the keyword over here, public or private. And as usual, I hope you notice all the patterns when making these new classes are you're making a bunch of member variables, constructors, move functions, and some getters and setters as needed. Pretty standard stuff. So again, here's another helpful slide that does the tedious part for you, is making asteroids. So here, like when you drew a spaceship, it was using coordinates starting with the upper left-hand corner, going clockwise for the number of vertices it has, and going back around. And so here's an example of one. Half the coordinates should be negative. To keep it centralized, remember the middle of your asteroid is 0, 0. That's how the floater system works, the coordinate system in there. And I guess you could introduce some randomness there. Notice that not all the asteroids here look the same. There's bits of variation amongst them. And so while making some of these coordinates, you have to be careful, like not to make them too like jaggedy, although that might be one of your intentions. Like you still have to keep it like solid to look its part. So there's some creative ideas for you to apply there. Some review of vocabulary. So the super and subclass idea, now that we have a hierarchy of objects and objects that depend on one another, when we have class spaceship extends floater, remember that the spaceship is called the subclass, the floater is called the superclass. I guess this is the most important vocabulary when talking about the AP test, although I prefer to use like the parent and the child class down here. Spaceship is the child, floater is the parent. And over here, you'll also see these words. The spaceship is derived from a floater. and the floater is the base class. Another reminder, we talked briefly about these diagrams, and the part that's a little different than what you expect is that the arrow always points up towards the superclass. So you read an arrow as an is a relationship. So an asteroid is a floater. A spaceship is a floater. Right? Asteroid is a floater. Spaceship is a floater. A subclass is a example of the superclass. So where does this come in useful? It's like the you can't go the other way with these diagrams. You can't say a floater is not all floaters are spaceships, not all floaters are asteroids. Yeah, it's a one-directional arrow. You point towards your super, parent, or base class. So here's a new keyword. This is the super keyword. So there's two variations of that. There's super with parentheses and super with the dot. So the yellow one up here, super with parentheses, it calls the constructor of the superclass. And it's generic, right? You don't have to say like floater parentheses. Super parentheses takes the place of that. Super with a dot calls member methods of the superclass. For example, your floater class had a move, and if you wanted to use that specific move, this is how you would do it. So one way to talk about the distinctions between these two, super calls the base class constructor. So this is the weird part. You've actually been using the super with parentheses. It's been hidden because anytime you make or you inherit, you create an object that inherits from like some kind of class. There is an invisible call to the default no argument super. So what does that mean? It's the default no argument constructor of your base class. So when you made a spaceship, there was one call to the floater's constructor. And that was called inside the subclass's constructor. You initialized like a bunch of variables there. Had you just left it blank, for example, you would have called just the floater class and it would have been initialized to whatever the floater did. If you like didn't initialize the member variables to your spaceship class. That's what keeps everything functioning. Even if you had a subclass where the constructor was blank, it still kind of works. So super.method, it does come up. I think about my own practice with software development. I don't know how often this has come up, but rarely, I would say. I don't remember. So the important part is if you need to access the private variables of your superclass, then you would likely use super.method. So take a look here. A short coding example. Where is the error that occurs? Subclass extends superclass. MyNum is a member variable that is within the superclass. And this call inside the constructor for the subclass 3 throws you an error. And notice how it's being called, yeah? Because superclasses MyNum is private, this thing is not allowed. 3 would initialize the MyNum variable of the superclass to be 3. That's what you want to do, but you can't. So one call with a super here is what fixes that. notice that the call, let's see, it's like the one that causes an error, yeah? This one causes an error, my num can't be accessed. Here, super.num passes in that value of 3 into the superclass constructor, and now notice the difference here, yeah? Inside the superclass. Now this specific constructor that I'm highlighting is being called, and then you can get num. Right, because Bob is a subclass, it inherited from the superclass. This works. Strange too, because like here you notice that the computer isn't smart enough to know to call the one argument constructor. Well, it's not, I mean, I guess that's I misspoke, right? Because this one you want to access the member variable mynum directly. That's what makes it illegal. This one's okay. When will this be used? I guess depends on how you initialize and write your constructor for your asteroid. So the other thing you'll need to do is override the move method. So floaters move in a certain way. You tied previously in the asteroids function, asteroids class, you tied the move function to certain key presses, right? Like to turn, to accelerate, to hyperspace. But for asteroids, there is no key pressing. Yeah, they move by themselves. So your job is now to override or overwrite. Override is the formal term. The move function present from floater. So they have to turn every time they move. So the skeleton of what you have, this is an example of something that will be located inside your asteroids class. So you have to turn some amount of degrees. The rotation speed is a new member variable introduced into an asteroids class. Where did that come from? We jump back to the beginning slide over here, slide 3. Notice this thing, yeah? Positively, randomly positive or negative. So they can spin clockwise, they can spin counterclockwise. Rotation speed is exclusive to just an asteroid, and then you borrow all the things over from floater, like the coordinates, the color, the, what else is there? Its speed, its direction. Okay, so we got the turning. And then they move like a normal floater. So you could just copy and paste the move code from floater, as seen in yellow here. But of course, there's going to be a better way. You know object-oriented programming. So if you find yourself copy and pasting code from the base class, it's likely, why not just call the method instead? Or rather, you should have a function there to call instead of copy and pasting. So in just 2 lines of code, turn with your rotation speed, and now you see an example of that super keyword. We're calling the floater class's move function, super.move. And now your asteroid, you should have like a single asteroid made that rotates in place and then floats in a certain direction. When it goes off screen, it appears in the appropriate spot. Yeah, that kind of wrapping, having infinite canvas size, the illusion of infinite canvas size. So as a reminder, something that's different here is that you'll have to add in your new file. You are making an asteroids file. In part 1, everything was kind of done for you already. But since you created an asteroid class, you have a new asteroids.pde file. The line of code you need to modify has to recognize that new asteroids.pde file. Be sure to make that addition. So with what I've gone over so far, when beginning part 2, you can create your asteroids class making a single asteroid. For us, it is tomorrow's lecture, no, Wednesday's lecture. We talk about an array list. It's a little different than an array to get a bunch of asteroids to display on the screen. And after Wednesday's class, you'll be able to complete the entire assignment. Also, posted on Google Classroom is some array list practice. If you want to begin it, they're rather simple exercises on how array lists work. You can begin working on that before I talk about array lists formally on Wednesday for you all. Okay, so that's all I have to say. Short class today, Monday class. Welcome to stay another 5 or 10 minutes if you want to work on problems together. I gotta do some grading to catch up on. Any questions? All right, so